Assalamu alaikum, my name is محسن المحسن. In this video I'm going to explain how to answer this question. Let's start. Uh, he says question states a hollow cylindrical steel shaft is 1.5 meter long and has inner and outer diameters respectively equal to 40 and 60 millimeter. So A, what is the largest torque that can be applied to the shaft if the shearing stress is not to exceed 120 megapascal? B, what is the corresponding minimum value of the shearing stress in the shaft? Okay, so let's put the data here. So L equal to 1.5. Okay, that is better. It's okay. Okay, let's put the details. L equal 1.5 meter, and he says the inner it's mean the 40, the C1, the D1, sorry, it's 40 millimeter, so we divide by 2 to get the radius. It will be 20 millimeter, so it's mean 20 times 10 minus 3 meter, and the outer is the second diameter, the 60 millimeter. We divide by 2 to get the second radius. It will be 30 millimeter, so equal 30 times 10 minus 3 meter. So he says at A, we put here, what is the largest torque? So he wants the torque. There is a rule. It says shearing stress equal torque times the outer radius over the moment of inertia. So we need the torque right now. We need the torque. So we multiply. We just put the torque multiplied by second radius, the outer radius equal the shearing stress multiplied by the moment of inertia. We divide by the outer radius, we cancel, then we can get the torque. So it says in the question that if the shearing stress is not to exceed 120 megapascal, so the megapascal here, it's 120 times 10 power 6 times. Okay, we don't have the moment of inertia yet, so we take the moment of inertia equal, it says in the question a hollow cylindrical, so the rule of hollow cylindrical, half times pi times brackets outer radius power 4 minus the inner radius power 4. So half multiplied by the pi, and then put the outer radius 30 times 10 minus 3 power 4 minus 20 times 10 power minus 3 power 4, close the brackets. When you calculate it, you will get 1.021 times 10 power minus 6, and the units for moment of inertia meter power 4. So you will put in the box. Okay, then we put here, it will be multiplied. It's better to put in the bracket. Okay, 1.021 times 10 power minus 6 over the outer radius is 30 times 10 power minus 3. So you will get 4084 Newton times meter. So this is the largest torque that can be applied to the shaft. So now he also wants the corresponding minimum value of shearing stress. So he wants the shearing stress minimum. Okay, there is a rule: shearing stress minimum equal the inner radius C1 over outer radius multiply by the shearing maximum. So min equal, we already have the inner and outer radius. We put 20 over 30 multiply by 120. You will get 80 megapascal. So you're gonna question that why we don't put times 10 to the power minus 3. I'm gonna tell you why. Like, if you put, okay, I'm gonna do it here. If you put 20 times 10 to the power minus 3 over 30 times 10 power minus 3, so automatically you will delete it. So no need to put times 10 to the power minus 3 times 120 megapascal. Why? Because of shearing minimum or maximum, the units of shearing stress is megapascal. So we don't need to transfer a megapascal to pascal, because at the end you're supposed to change the pascal to megapascal. So 20 over 30 times 120 will get 80 megapascal. So I hope this video is useful to you, and I hope you understand by my explanation, and thank you for listening.